Hello there, this is Homer Cocktail 17, a mathematics channel. Doing tutoring on many of the basics we've already covered. Arithmetic, geometry, algebra. We're going to do trigonometry right now. We'll get to calculus next. And what is trigonometry? In my words, I'd say it's a math of emphasizing angles and lengths. The etymology from Wiktionary pretty much says it's a relationship between sides and the angles, etc. So pretty close from my memory. Punting in football. If you've ever seen punting in football, what you'll notice is referees get together because they're triangulating. A ref stands behind the punter, points in the direction of the punt. A line judge further down tells where the punt goes out of bounds, if it goes out of bounds, and they come to a conclusion about where the punt leaves the field of play. If you've seen people on side, surveyors, engineers, they are using trigonometry to figure out where they're going to post certain stakes, wooden stakes, and measuring the heights of buildings, whatnot. If you've seen grade signs, we're familiar with 8% grade or whatever. We're dealing with the angles here. Trigonometry is about triangles, and we're going to figure this out. Skateboarders know about doing a 180, which is basically going the opposite direction of the where you had been going. These are protractors, which are 30 degrees. These are used by draftsmen, people that do drafting. 30, 45, and 60. There are three different angles here. So we're going to do a quick geometry review. That's 90 degrees, a right angle, signified by the little square, the tiny square. Okay? If you bisect that, that means if you take half that angle, you're going to have 45 degrees. You see? From the maroon up to the purple, you have 45, and that's one line. The second line, we could use a single line again since they're the same exact angle, but it's another 45 degrees. The point being here, get to 45 degrees angles, you're going to wind up with the 90 degree angle, a right angle. Okay? Alright, so we're going to move on. A square, 90 degrees at each corner. And what you'll notice at the top of this page, 90 plus 90 plus 90 plus 90, 4 of those angles is 360. This will be true inside any four-sided shape. Even if it's a rectangle. Even if it's a parallelogram. This is a parallelogram. And if you remember this, alternate interior angles are always equal. You have 45 degrees where there's single swipes, and 135 degrees where there's double swipes, once again equaling 360 degrees. Now a triangle always equals 180, which is half of 360. This is an isosceles triangle where each side is equal, signified by a single line on each of the sides. If there's a double line, it means it's different size than something else before it. But this is 60 degrees on each side, totaling 180. Now what we have here is a right triangle. 45 degrees on 2 of the corners and 90 degrees at one of them, once again equaling 180. Now if you remember that protractor, we had 30 degrees, 60, and 90. The ancient Greeks figured something interesting out. How they figured it out, I'm not really sure if it's trial and error or whatever. They figured out that if you get this kind of proportion, you're going to find something very interesting, where the height is 3 and the length is 4. And once again, you'll notice 30, 60, 90 equals 180. Okay, we're going to call that vertical blue line the y-axis. We're going to call the horizontal blue line the x-axis. Now we're at trigonometry, folks. We are now at trigonometry. Okay? Because what we're going to do is figure out this great formula that's a couple of millennia old. A squared plus B squared equals C squared. On the right, you're going to notice that we're going to signify the vertical line in that triangle to be 3 units high. The horizontal line along that triangle, that maroon triangle, we're going to signify it as B. A is 3 units, B is 4 units, you can notice. We're going to try to figure out C using that equation, a squared plus b squared equals c squared. That C is called the hypotenuse. The hypotenuse is the longest little beam in the triangle, by the way. And here we go. Da, 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 da. Okay, we got 3 squared because A is equal to 3. Okay, if you substitute the first part of a squared plus b squared equals c squared, 3 squared at the top of the page, that's not 32, that is 3 squared. Okay? In higher math, that number 2 is called an exponent. And that really means you're going to take the bigger number on bottom and multiply it by itself however many times the smaller number on top. In this case, we're going to take 3 and multiply it by itself 2 times. So it's 3 times 3. In higher math, we don't use that little x, we use a little dot. And now we're going to substitute b squared for the number that we have on the bottom, and b is 4 units long. Now we're going to try to figure out what c is based off what we know here. 3 squared plus 4 squared equals c squared. 3 times itself is 9, 4 times itself is 16. That's equal to c squared now, written in purple. Okay? Now, 9 plus 16 is 25. So c squared is equal to 25. Now what we're going to do is take the square root of both sides so that we isolate c by itself. Square root of 25 equals the square root of c squared. In higher math, what you'll know is that there's a cubed root, a fourth root, etc. But when we write square root, we don't write a little number where that little v is, but it's inferred to be there. That cancels out the 2 on the exponents. The square root of 25 is 5. The square root of c squared is c. Okay? So that's our answer. The hypotenuse, represented with 3 strikes on the length of the beam there, is 5 units long. And this is trigonometry, okay? Now we're going to define the far beam is y, the bottom is x, and the hypotenuse is r, meaning radius. The angle is going to be a 0 with the backslash. Sine is equal to y over r. Cosine is x over r. Tangent is y over x. Those are the 3 main ones. Now we're going to go to their inverted buddies over here. Secant is r over x. Cosecant is r over y. Cotangent is x over y. From here, nothing but fun, buddies. If you draw a line to the left and downward from your x and y axis, you go into the negatives, okay? And if you continue that radius all the way to the left, it's going to hit 180 degrees, you see. You continue it until you start where you begin. That's 360 degrees, a complete turn. 180 is pi, 360 is 2 pi. Okay? This has been Trigonometry. You guys been a good crowd. And party on! Have a good time.